For over 2 decades, the Cassini spacecraft graced our solar system, a lone sentinel orbiting the majestic Saturn. But on September 15, 2017, Cassini took a final, fateful plunge, burning up in Saturn's atmosphere. This wasn't a tragedy, but a deliberate act, a grand finale orchestrated to protect the pristine environments of Saturn's moons. Cassini's mission was one of exploration, of pushing the boundaries of our understanding. It spent 13 years orbiting Saturn, sending back breathtaking images and groundbreaking data. But why destroy such a valuable asset? What secrets did Cassini uncover during its long vigil in the Saturnian system? And how did its discoveries reshape our understanding of the cosmos and our place within it? Join me, fellow space enthusiasts, as we delve into the remarkable journey of Cassini, exploring its groundbreaking discoveries and the legacy it leaves behind. Let's start with the most iconic feature of Saturn, its rings. These rings have fascinated astronomers and casual stargazers alike for centuries. We've all marveled at their beauty, often through telescopes or stunning images captured by spacecraft. But Cassini showed us they're not just static, unchanging structures. Instead, they are full of motion and life. They're a dynamic, ever-evolving system constantly influenced by various forces. Imagine a cosmic ballet with countless particles of ice and rock, ranging in size from grains of sand to small mountains, all swirling around Saturn in a delicate gravitational dance. Each particle plays its part in this grand performance. Cassini revealed waves and braids within the rings sculpted by the gravitational pull of Saturn's moons. These moons act like cosmic sculptors, shaping and influencing the ring's structure. It showed us ringlets, these intricate, fine-scale structures that weave through the rings. These ringlets are like threads in a vast cosmic tapestry, and it gave us clues about their age. Scientists have long debated the age of Saturn's rings, and Cassini provided valuable data to help solve this mystery. It turns out, these majestic rings might be surprisingly young, perhaps only 100 million years old, a blink of an eye in cosmic terms. This discovery was both surprising and enlightening. That means they weren't formed with Saturn billions of years ago, but much later, maybe from a shattered moon or a captured comet. This origin story adds another layer of intrigue to Saturn's rings. Think about that. The rings we see today, those iconic symbols of Saturn, might not have been there when dinosaurs roamed the Earth. This perspective connects our planet's history with the broader story of our solar system. They're a reminder that our solar system is an active, evolving place, and even the most seemingly permanent features can have surprisingly dynamic histories. Saturn's rings are a testament to the ever-changing nature of the cosmos. Next, we journey to Enceladus, a moon that captured our imagination and redefined our search for life beyond Earth. Before Cassini, Enceladus was just a tiny, icy world, a blip on the cosmic radar. But Cassini changed everything. It discovered something incredible. Geysers erupting from the moon's south polar region, spewing water vapor and ice particles hundreds of kilometers into space. Imagine that. A moon, smaller than the width of Texas, with active geysers. These weren't just any geysers. Cassini flew through these plumes and found they contained water vapor, organic molecules, salts, and even hints of silica dust, which likely forms in the presence of hot water interacting with rock. This pointed to something even more astonishing, a global subsurface ocean hidden beneath Enceladus's icy shell. This discovery was a game-changer. It meant that Enceladus wasn't just a ball of ice, but a potentially habitable world, with liquid water, organic molecules, and a source of energy, all key ingredients for life as we know it. Suddenly, this tiny moon became a prime candidate in our search for extraterrestrial life. Now let's venture to Titan, Saturn's largest moon and a world that's both eerily familiar and utterly alien. Titan is a place of stark contrasts and fascinating mysteries. Titan is shrouded in a thick, hazy atmosphere, making it impossible to see the surface with ordinary telescopes. This dense haze is composed of complex organic molecules, creating a golden-brown smog that envelops the entire moon. But Cassini had a trick up its sleeve. It carried a special probe called Huygens, designed to descend through Titan's atmosphere and land on its surface. This mission was a monumental step in space exploration. In 2005, Huygens made history, touching down on Titan and sending back the first-ever images from the surface of a moon beyond our own. These images provided an unprecedented glimpse into an alien world. What we saw was breathtaking, a world sculpted by rivers, lakes, and seas just like Earth. These features suggested a dynamic and active environment, but there was a twist. These weren't filled with water but with liquid methane and ethane hydrocarbons that exist as gases on our planet. This discovery was both surprising and intriguing. Imagine a world where methane rain falls from the sky, forming rivers that carve channels through a landscape of water ice, eventually flowing into vast methane lakes and seas. This cycle of methane is similar to the water cycle on Earth, but with a completely different substance. It's a bizarre, captivating world, and Cassini revealed it in all its glory. The mission provided invaluable data that has reshaped our understanding of Titan. It mapped Titan's surface using radar, revealing mountains, dunes, and even evidence of cryovolcanoes, volcanoes that erupt with ice instead of lava. These findings suggest that Titan is geologically active, with processes that are both familiar and alien to us. Now, let's turn our attention to Saturn itself, specifically its atmosphere. We often think of gas giants as being relatively calm and unchanging, but Cassini showed us just how dynamic and turbulent they can be. It witnessed gigantic storms raging across Saturn's face, some larger than the entire Earth. One of the most striking features Cassini observed was the bizarre hexagonal jet stream at Saturn's North Pole. Imagine a six-sided storm, a perfect hexagon, larger than our planet, swirling around Saturn's pole. It's a phenomenon unlike anything we've ever seen in our solar system, and scientists are still trying to understand how it forms and why it's so stable. Cassini also tracked seasonal changes on Saturn, observing how the planet's atmosphere changed over its 29-year orbit around the Sun. It saw the colors of Saturn's bands shift and change, and it witnessed the formation and dissipation of storms. These observations helped us understand the complex atmospheric dynamics of gas giants and provided valuable comparisons to Jupiter, our solar system's other giant. Cassini didn't just focus on the obvious, it also delved into the invisible forces shaping the Saturnian system. This mission was not just about capturing stunning images of Saturn and its rings, but also about understanding the unseen dynamics that govern this distant world. One of its key tasks was to study Saturn's magnetic field, a vast bubble of magnetism that surrounds the planet. This magnetic field is a protective shield, deflecting solar wind and cosmic radiation, much like Earth's magnetic field does for our planet. What Cassini found was surprising. Saturn's magnetic field is remarkably aligned with its rotation axis, unlike Earth's, which is tilted. This perfect alignment puzzled scientists and led to new theories about the internal structure and dynamics of Saturn. This alignment was unexpected, and challenged our understanding of how planetary magnetic fields are generated. It suggested that the mechanisms driving Saturn's magnetic field might be different from those at work in other planets, including Earth. It also meant that Saturn's auroras, those beautiful displays of light in the polar regions, behave differently from Earth's. These auroras are influenced by the unique characteristics of Saturn's magnetic field, creating mesmerizing light shows that are unlike anything seen on our home planet. Of course, no exploration of Saturn would be complete without its diverse family of moons. Each moon has its own story to tell, and Cassini was there to listen and record these tales. Cassini studied 62 of them, many of which were poorly understood before the mission. These moons range from tiny, irregularly shaped rocks to large spherical bodies with complex geologies. It revealed their unique characteristics, from the heavily cratered surface of Mimas, which bears a striking resemblance to the Death Star from Star Wars, to the two-toned moon Iapetus, which looks like a cosmic yin-yang symbol. This moon's stark contrast between its dark and light hemispheres remains one of the most intriguing mysteries of the Saturnian system. And let's not forget those mysterious propeller features Cassini spotted within Saturn's rings. These features are small, propeller-shaped gaps in the rings that hint at the presence of tiny moonlets. These are thought to be the gravitational footprints of tiny, unseen moonlets, which are too small to be directly observed but have enough mass to influence the ring particles around them. Objects that are too small to be seen directly, but massive enough to clear a gap in the ring material. These gaps provide valuable clues about the processes that govern the formation and evolution of moons. They're a tantalizing glimpse into the process of moon formation, happening right before our eyes. Cassini's observations have given us a front-row seat to the dynamic and ever-changing environment of Saturn and its moons, expanding our understanding of the complexities of our solar system. Cassini's grand finale, its final plunge into Saturn's atmosphere, was a bittersweet moment. It marked the end of an era, but it was also a testament to the mission's commitment to protecting the pristine environments it had explored for so long. By crashing into Saturn, Cassini ensured that it wouldn't accidentally contaminate Enceladus or Titan, potentially jeopardizing any life that might exist there. Cassini's legacy is immense. It revolutionized our understanding of Saturn, its rings, and its moons. It revealed worlds more diverse and awe-inspiring than we could have imagined, from the geysers of Enceladus to the methane lakes of Titan. It challenged our assumptions about planetary systems and expanded our search for life beyond Earth. In its final moments, as Cassini plunged into Saturn's embrace, it sent back one last burst of data, a final love letter to the planet it had studied for so long. "So long, Cassini," we whispered. "You will forever be part of the planet you loved. Its mission may be over, but its discoveries will continue to inspire us for generations to come, a testament to the power of human curiosity and our unyielding desire to explore the cosmos."